Hello everyone, my name is Pratiksha Ramchandra Dabane and my roll number is 4120. Today I am going to present my ISC topic, that is Transaction Processing System and Enterprise Application in Distributed Cloud Computing. So let's first understand what is the Transaction Processing System. Processing System is also called as a TPS, which is the backbone of many enterprise applications. They handle various routine processes like order entry, payment, billing. It ensures the data integrity, speed, and accuracy even if the failure occurs. So let's consider an example. Whenever we go to an ATM, uh, uh, we withdraw money and whenever we withdraw money, the balance should be correctly updated. So the transaction payroll system is responsible for that. Now coming to the pillars of reliability, as I mentioned earlier, TPS is responsible for making the overall changes. The main part of TPS is that the asset properties from which the TPS ensures all the reliability and security. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So let's first understand atomicity. Atomicity means the transaction must happen at a time or none at all. This means that let's consider an example. In online net banking, whenever money is deducted but not credited, then transaction go to the pending step. It means that the transaction is not happened. Next is the consistency. The transaction must follow all the rules. Let's consider an example. Whenever we book a train ticket, and the TPS must ensure that the seat booked by another person should not be shown to the other person to book a ticket. Third is isolations. Transaction made should not conflict each other. Let's consider example. Whenever two people order a same last piece of same product, then the order should be placed to the only one person. Next is durability. Durability means the changes that are made should remain permanently on the database. Let's consider an example. Once a transaction is confirmed, it is saved permanently. It means that after a placing order on Amazon, even a system crashes, the even a server crashes, the order is recorded. Now, uh, Now coming to the enterprise application integration, businesses use many different applications that often don't talk to each other. EAI solves this problem by integrating the system, making sure data flows smoothly. This reduces manual work and avoid errors. Let's consider an order. Whenever we order food from a online app, then our order goes from the app to the restaurant system and then to the payment gateway. This is the EAI in action. Now coming to the common EAI points, as I mentioned in a diagram, are the point to point, hub and spoke, enterprise service, and message queries. So let's first understand what is point to point. Direct point to points means direct connections, simple but messy if there are many apps. Next is the hub and spoke. A central hub manages all the applications. Third one is enterprise service bus. In this, a smart middleware that routes there is a smart middleware and that transfers the data to the other hubs. Next is message queues. It is used for asynchronous communications, like sending WhatsApp messages that get delivered even when the other person is offline. Now let's understand the distributed cloud. Distributed cloud computing extends the cloud services across different physical locations like data centers, edge, or multiple providers. There are several benefits of distributed cloud computing like reduced latency, compliance, security, and reliability. Reduced latency means processing data to close users. Compliance means data can stay within a country's borders for legal reasons. And resilience means workloads are spread across locations for better fault tolerance. And scalability means resource can scale up and down whenever needed or whenever there is demand. Now let's understand how TPS plays role in distributed cloud computing. There are many advantages of TPS using a distributed cloud computing, but it faces some challenges like maintaining consistency across the regions. So to overcome this, there are two solutions. First one is a two-phase commit, that is 2PC, and next is eventual consistency. Let's understand what is two-phase commit. In two-phase commit, it ensures that all the servers commit a transaction together. All the servers commit transaction together, maintaining the maintaining the consistency. Next is eventual consistency. It is for non-critical data. Systems sync over time, like social media likes that appear after a few seconds. Now, enterprise application integration in a distributed cloud. In a distributed cloud, AI adapts with modern architecture like microservices, event-driven architecture, and API gateway. Microservices means breaking apps into the smaller independent services, so that no one model can be so no one model can be applied everywhere. So if there are change in one small part of the model, then when we use microservices, that only part of that model will be changed. So maintaining the scalability of an application. Next is event driven architecture. Each services talks using events and ensuring loose coupling. And the next is the API gateways. It is a secure entry points for managing APIs. For example, Netflix uses microservices and event driven architecture to handle and manage millions of requests per second. As we know that TPS ensures data security, speed, and reliability, but there are few things we need to mention while integrating TPS and EAI, that are data consistency across databases, latency management or for faster responses, security with encryption and authentication, and last one is the observability using monitoring and logging. All of this ensure a smooth TPS operations. Thank you.